Sounds good.
Right.
Sounds good.
We are now recording, so over to you.
Let's do it. Okay, thank you all, folks, for joining today. I think that today's is chapter 3. It's all about like pipelines and delivery for cloud native applications. I wanted to start like asking people because I couldn't join last week, where I think that Sevi was creating kind of like running the application in a cluster, which is great. Because that basically means that the examples worked and they are still working, which is something that keeps me up at night. I know that examples will break over time, and now that we are starting to go through chapters and people trying different examples, I just want to make sure that I keep them up to date and they keep running, no matter if the tools that I was using are changing or not. um, Pipelines was a very big topic, kind of like delivery in general, like creating containers. How do you create containers? How do you distribute them? And then how do you, create some sort of pipelines to run and create environments? And I got a lot of questions about that. And I think that before starting kind of like with the chapter, I wanted to say that I know that this is sometimes a very controversial topic, right? Like how do you do pipelines? Which tools do you use? And how do you approach the problems? It's really company specific, and there are like different, chains of thoughts. And you can do, whatever works for you. That's the whole idea. And I try to stay kind of like quite light on definitions, but I introduced a couple of concepts that made a lot of sense to me when I was writing these and when I was looking at different tools in the ecosystem. So by saying that, I just hope that you guys enjoy the chapter. And if you are reading it, great. And if you are not, I think that today we will just go through the content, and we will stop at any point to discuss any questions that you might have, or any other topics that you think that are related to the topic of pipelines. The chapter specialized like focuses on service pipelines, which are the pipelines that I consider closer to developers, because developers will be making changes to the services and then making sure that new releases of those services are being put out for the operations teams to basically deploy in different environments. I think it's really important to, at least for me, initially this was like a very long chapter covering like how do you build services, and then how do you deploy them in different environments. And then I made that decision of separating those two things into two separate chapters. The first one, it's mostly about how do you build your services and what are the things that you need to consider when you're doing so. And in order to explain a little bit more of the topics, I went and picked a couple of tools from this, from the cloud native space, like Tekton, Dagger, and I wanted to compare that with GitHub Actions. And the advantages of some tools and the disadvantages of others creates kind of like an ecosystem that it's pretty interesting, and you will need to understand in order to make the right decisions. I could have chosen, going and covering like tools like Jenkins or only GitHub Actions because it's very popular, but I wanted to have like a wide spectrum of tools that are doing things in completely different ways, but kind of like with the same purpose, right? Remember that we are in the context of platform engineering, so I wanted to tie that back to how these tools relate to platforms in general, and and just show different options of what I've seen people doing out there in the wild. Any questions before I start? Any comments or any things that you might want to raise before we go through the main structure of the chapter? Let's see the chat. I don't see anything in the chat, but if there are no questions, I guess that I can get started. This is again, it's chapter 3. It's titled Service Pipelines, Building Cloud Native Applications. Remember always that I wrote this book with a heavy focus on kind of like the developer perspective, right? Like the user, like the people who is creating new features for the business and trying to deliver these applications towards different environments, while they are working locally or where they are working remotely on clusters, on remote clusters, if that's the case. So let's get started by looking into how this looks, like how the chapter is structured. The first part is all about like more like the reasons why I thought that this topic was important, right? Then I go into kind of like trying to describe what the service pipeline is in my opinion. And again, I'm calling it service pipeline because they have a one-to-one relationship with the services inside of your applications. If you're building cloud native applications with multiple services, then my by default logic is that you will have one service pipeline per service, but it really depends on what you're doing. You might want to aggregate multiple services that are all related to each other in the same service pipeline if you need to. So there is no strict definition there. It's much more like a concept that you can use to follow and organize your thoughts around. So first, I start with that like short definition of what the service pipeline is. Again, very lightweight definition. And I also discuss a little bit at the beginning, what does it take to deliver cloud-native applications continuously, right? Because in my experience, I've seen a lot of people using, for example, Kubernetes without actually benefiting from all the mechanisms that Kubernetes gives you, like continuously releasing applications, like new versions, and making sure that you can just actually keep rolling, new versions forward instead of stopping everything, the entire application, all the services, and just deploying a new version. So I wanted to touch on that a bit. That's why the first part of the chapter, it's a little bit more about what are we trying to achieve and what kind of mechanisms in Kubernetes we want to use to achieve that, right? Some of the things that I've seen team doing is that like you have multiple teams building different pieces inside of the application, and in order to get all those pieces in the same place, in the same environment running, you actually need to coordinate how these services are being built and how they are being published, so the operations teams can put them together in the same place. And to realize that the fact that services in distributed applications will evolve differently at different paces, and you need to optimize to make sure that no matter when a service kind of has a new feature and it's ready to be deployed, you can just streamline all the process from getting kind of like all these changes from the developer's laptop to your production environments. What I mentioned before, right? Making sure that we can upgrade a service without breaking or stopping all the other running services. I think it's important. There is a combination of things that you need to do in order to achieve that. It's not that simple of saying, let's just keep updating services. It's like you need to use the right tools, but also you need to build the application in a certain way to be able to do that. And then there are tons of things that, at least from a developer perspective, are painful, right? Like, creating, for example, a container registry and maintaining it and configuring it so it's secure. All that kind of things, it's just complicated. So if we start working with containers for like running our workloads in Kubernetes, that's an extra thing that developers doesn't want to deal with, right? Like they want to just code their features, and they need automation to make sure that these things gets containerized and also published to the right place. So when you try to run those workloads in a cluster that it's across the world, like in the other side of the world, those containers can be fetched and they can run. And finally, like managing and provisioning environments as well, right? Like again, here in this chapter, I'm not focusing about environments themselves. Like that's the next chapter. That's environment pipelines, chapter 4. But I wanted to mention this here because at the end of the day, we are building services that will be deployed in an environment. So we need to make sure that it's we have a streamlined process to get there. Diagrams here, like very, very basic. We have the source code. We want to get our service running in an environment, let's say the staging environment. Then we need some kind of like a pipeline. And pipeline is basically just again, I'm using this term because it's very well known in the industry. It's just a set of tasks that needs to be performed in order to achieve that, right? And usually you will have something like a pipeline engine that will allow you to automate these tasks and the sequencing, right? And making sure that you can keep track of which tasks were executed and where the artifacts are. So I go there, I try to explain a little bit that, like the difference between what the pipeline definition is and what the pipeline engine is that will pick pipeline definitions and run them in an environment to produce real artifacts and to do stuff, to do work. So I try to show that most of the time when you have a pipeline engine, you will have those concepts, right? Like the definition itself that is static, and then the actual running pipeline instances that will run inside the engine, and they will be kind of like stateful in a sense, right? Like they will have a state. They are running, or they already finished successfully, or they failed, right? And then you can drill down into tasks, and I'm using these terms, but sometimes they are called activities or steps, right? Like it really depends on the pipeline engine or their nomenclature. But in this case, I chose to go for the simple thing, like you have pipelines and you have tasks inside the pipeline. And again, this can get really, really complicated. I didn't want to go and explain how all the pipeline engines in the world works because they all have their different subtleties, but just as an introduction of the mechanisms that we are going to use to actually produce our artifacts and build software and automate all these steps that we need to automate nowadays. Yeah, and again, I just try to say, okay, we are going to focus on kind of like on the service pipelines, which is basically taking our source code and producing artifacts that can be distributed. Any questions so far? I know that I'm talking a lot, and this is supposed to be more like an interactive session, so happy to take questions at any time. Feel free to interrupt me, and I'm going to switch to the chat just to see. The book content on the share screen. I'm not sharing. Is it not shared?
You're not sharing.
Damn it. Thank you very much. Yes.
Now you're sharing.
Okay. So basically what I was doing so far was just showing kind of like these diagrams while I was talking through kind of like the different introduction sections, but let's go through that. I guess that's just purely introduction. I stopped here like the service pipeline place, which is basically when I start just going deeper into how kind of like a typical service pipeline will look like, what are these pipelines doing, and why I think that it's important to in some way standardize these for the services that you're building, right? And then I think that like go through that, right? Like I go through like industry-wide conventions that will save you time, right? There is no need for you to go and say, I need to stop and think what my pipelines are going to do if you can go and copy some very well-known, methodologies and practices, like, for example, trunk-based development, right? So I got to explain here again very, very lightly what the idea is. The idea is that you have the main branch of your repository. It's the like always releasable branch, and then you can create, feature branches to work on features. So teams can be working while there is a releasable branch all the time. Whenever you have a new feature to merge to the main branch, you need to run all the checks to make sure that whenever you merge that, your main branch is always releasable. So I talk a little bit about that. I talk about like configuration managed source code and configuration management. This is important, and it's all about like where do you store your software. We are all using GitHub or some sort of Git repository nowadays. So I didn't thought to spend much time just discussing about that, but I thought that it's kind of like important to mention that there are like again different thoughts, different schools of thoughts about like how do you organize your software. And I am not in favor on any of particular, right? Like you can have like tons of repositories and one service per repository that will end up in one pipeline, or you can work with mono repositories where you have tons of different services, the source code of the service in the same Git repository, and then you can trigger pipelines that are just looking into different directories, for example. Up to you how you do it. I just wanted to make sure that there are like different options being listed here. And of course, that there are like entire books that you can go and read about like, how to organize your mono repos, or the advantages of having one service per repository and creating pipelines for like repository wide. It's kind of funny when you start thinking about where do you store your source code, it becomes also like a platform problem, right? Like now the platform, it's not only about the runtime part of things, but also how do you create new repositories for new services? How do you initialize those repositories? And how do you standardize for teams to have some kind of like the same starting point when they create new services and projects? And finally, I just want to make sure that no matter what we are doing, testing, it's going to become a thing at some point, right? Probably early on in the process. If you are running pipelines to create artifacts, you will be running tests. And some of those tests are integration tests that are not related with a single service, but maybe with multiple services. And I found that, like consumer-driven contract testing is a really good approach for solving some of these challenges. And again, it's a topic that I'm pretty sure that there are like at least 3 or 4 like very, very long books on this. And there are tons of tools on that space too. This is where it becomes a little bit more complicated because most of these tools are technology stack specific. So I couldn't pick one and just say like, let's cover that tool because it will show for everyone in different communities kind of like what the purpose is. But again, if you look for that term, consumer-driven contract testing, you will find a lot of interesting tools that you can use to simplify the testing in your pipelines. Yep, there are a bunch of books that I recommend here, like, of course, Continuous Delivery. That's kind of like the Bible of this topic in general. And again, it's not using the same kind of like nomenclature that I'm using. I'm just trying to summarize some of the topics together here. And then Grokking Continuous Delivery by Christy Wilson, too. It's really important. Christy was part of the Tekton project that I'm mentioning here as well. So I consider that she kind of like knows what she's talking about in that book. And when you take a look at the Tekton project, you can see that there is a lot of thought behind it as well. So yeah, I just try to kind of like create a simple introduction, some topics that you need to know before jumping into service pipelines, and then I just go straight through like, okay, what is the service pipeline all about, and what are the main things that you will find in a service pipeline. Again, this is pretty high level because I know that in real life you will go and do a lot of other things in these pipelines, but most of the time you will need to do these kind of things, and most of these things are already standardized in the tools that I'm showing kind of like in this chapter. So you have steps in pipelines or tasks, right? And usually everything starts by like getting notifications from your source code system, right? Like Git, you get like a push notification that there's a new commit in your main branch. So that basically means that you will need to trigger a pipeline. And then the most common steps is like cloning the source code, right? Like you need to get the source code that you're going to build or package, depending on your tech stack, and then probably creating tags. So if you're planning to release that build, then you will just need to have a tag to be able to release the artifacts under that tag. And then, of course, build and test the source code. That will depend on the tools that you're using. And there are like some tools that you can actually use to make your just to make sure that whatever your pipelines are producing are up to the standard, like codecov that will check code coverage and how much code that you're pushing is being tested, or security scanners to check that your dependencies doesn't have any new CVE like vulnerabilities and that kind of stuff. And you can use all this information to say, okay, I don't want to continue my pipeline to the next task if I'm finding like some vulnerabilities that cannot be released to my production environment, for example. The same with the code coverage and tools that will just format the code and make everything a little bit cleaner and production ready. That's kind of like important. And I think that it's like most of the time I will be thinking about getting the source code, creating a tag, or just figuring out which new version will be created by running this build, building and testing, and then finally packaging and publishing kind of like binary artifacts to artifact repositories, right? And this is like, it could be like building a container, or there are some technology stacks that will need to distribute a binary as well, right? Like the binary that usually will run inside the container. It really depends if you need that binary or not, depending on how many options do you have to run your applications. But yeah, in the context of Kubernetes, we will just always try to produce a container that it's been stored in a container registry somewhere, right? I mentioned some tools here, like for example, CNCF build packs, which is something that I mentioned here, but I don't go super deep into it because other tools are using it. But the idea behind build packs is to try to remove kind of like the idea of having a Docker file to create containers. So if you don't know anything about build packs, please check it out, because I think it's kind of like an interesting tool that do kind of like a very important job of saying, you just give me your source code, I will give you a container back, right? That's the main point there. And then it has kind of like different layers to enable teams to say, okay, but in my company, when I create a container, I want to make sure that I'm using this base image, and I'm performing all these checks to make sure that my container is production ready. So Buildpacks gives you kind of like all these tools to do that. And it also gives you the possibility to patch images. Like imagine that you find a CVE, you don't need to recreate the entire image, but you can just patch different base layers. So again, you optimize for like production use cases. I think that's kind of like the gist of it, like building, publishing, creating containers, publishing the containers, and finally, because again we are in Kubernetes, we need to figure out like a way of packaging and versioning kind of like YAML manifests or like resources, Kubernetes resources. You can use Helm if you like that kind of stuff. You can use Customize, but you will need to in some way manage and version these artifacts, because again, if you want to reproduce, if you want to run the same application in multiple environments, you want to make sure that not only the images are the same, but also the configuration for those workloads are the same. Yep. And then again, like up to you. Like if you use Helm, you can publish that into a Helm repository, or like like OCI container registry nowadays, because you can also package Helm chart as containers. So you can just reuse the same registry for that. And finally, I think that that's kind of like important too, is like when you create a new version of a new of service, you need to notify all the interested parties, right? And this really depends on what kind of software are you building, right? Like in an open source project, we never think about notifying all the people who is using the project that there is a new version, like with a push notification or something like that. But in companies where like you have 3 or 4 environments, you can actually create an automation there just to make sure that the environments are aware that there's a new version of this service ready to be deployed, right? So how do you implement that? There are like different tools, and there are different ways that you can do that. And I think that I got initially this idea from a tool that I was looking that basically automatically created pull requests whenever like a build finished. Like you finish the build, you publish the container, and then you can actually create a pull request to the environments that are registered as like interested parties to receive new versions, upgrades. That's kind of like the gist of it. It can get really really complicated, but I go through that like through the main steps here, like in the diagram, which I'm trying to summarize all the steps that you might find. And then I try to basically say, okay, this is kind of like what a service pipeline is, at least in my head conceptually. You will do much more many things in real life, but conceptually you should find kind of like these steps. And I think that this is where it becomes a little bit more interesting, because now again, the only thing that the developer should be worried about in this case is just writing code, writing new features, and creating these feature branches that when they are ready, they are going to be merged to the main branch. At that point, when they are merged, this pipeline should run to produce new versions of the artifacts. And to get all that stuff working in the right way, you will also need to have pipelines to check the feature branches to make sure that they are consistent and that they are releasable, right? So that's kind of like the generic description. I go into explaining a little bit of the details there and the things that you need to be aware of. But I want to make a stop here. Now that I'm sharing my screen and you have seen kind of like what I've covered so far, I wanted to check if anyone has any questions.
I have a quick one, Mauricio.
Go for it.
Uh,
Yes.
you were talking about Artifactory and also container registry.
Mhm.
What's the best practice you recommend using a different domain for example, different method to store artifacts, and another way, separate a repository, container registry for storing the validated containers? What is the best practice? Or together, for example, in Artifactory, you store both artifacts and containers. What is the best practice?
That's a good question, and it really depends. I think that there are like no best practices unless you go into a very specific community, right? I'm coming more from like the Java community, where you are very interested in distributing, for example, your jar files that you will generate, because you might want to deploy those jars, or you might want to run those jars in different ways, like maybe for local development or for some local testing without using containers. In that case, using something like Artifactory makes total sense. But sometimes there are like some ecosystems where like let's say that you are running your applications only on Kubernetes and you are building Go applications. There is no need to create and publish that binary separately if you don't want to run them, right? Like maybe you have a scenario where you want to run them, but if you don't want to run them, you will always publish the container. In that case, using the container registry alone, I think that it's more than fine. I don't know if people have more inputs into that, but it's really up to the use case, and it's really up to if you want to run the binaries alone or not.
Yeah, makes sense. Yeah. Thank you. Thank you, Mauricio.
Can you, Rajesh, can you mention kind of like what kind of technology are you using, just for me to have a little bit of context?
It's as you stated, Java. It's a typical
Yeah.
Java environment. We have a separate thing for storing artifacts, and also a separate
Mhm.
registry to contain, to generate and store the containers.
I think that makes total sense to me. Again, like coming from that kind of like background, I think that makes sense. I've seen that so many times. Yeah.
True.
Good. Any other questions?
I wanted to comment, so it didn't sound like I was being too critical in the comments. The trunk-based development piece was interesting because it's you have a different definition than what I'm used to with that.
Perfect.
What I used to work with Paul Hammond, who wrote the website I linked in there, so disclaimer. And trunk-based development, from what I've always seen, is trunk is always continuous integration always happens in one branch called trunk or master, depending, or main or whatever you're on. And all changes go in. Branches are very minimal, very short-lived. And yeah, Carlos, I also am a TBD evangelist, but your mention of feature branches caught my eye, because that's usually in the contracts I've been on and the customers I've been at, it's always been, we need to get off these long-running feature branches because we have too many developers and it's killing us, because Team X over in this office or in this region is working off of that feature and this feature, and merge hell, it kills you. So anyway, I don't want to take it down a rat hole, but it was just interesting to see a different take on TBD than I've seen before.
I think that they are that's really open to discussion. I think that Jack also has its hand up. Yes, sorry, Jack, I'm not seeing kind of like the faces. So yeah, go ahead.
I'm sorry, I'm here. Hi, can you hear me? Okay. I just have a simple question. My company and our practices and our platform engineers set things up a certain way, and we're doing it a great way. But our product has to fit into my customers' platform engineering environment. And some of my customers are centered around Google Cloud. Some of my customers are centered around the tools associated with OpenShift. And so I've got a product that's developed in one environment, but it's being delivered into my customer's environment, and it's different. Do you talk about that in here? Is there a best practice around that, or is that really orthogonal to what you're talking about?
I think it's orthogonal. That's a good point. From what I'm hearing you describe, basically you have different kind of like environments, or it's not only environments, it's like different delivery places, right?
Yeah,
like
I'm making a product and I'm delivering it to my customer's Kubernetes environment. And their environment, I'm an input to it, and I have to go through their CI/CD flow. But their CI/CD flow is different from mine.
Perfect. And there is a problem there, or what's
yes,
it's a much more complicated version.
Because I got one customer, and by the way, my customers are always right. One customer has their workflow more or less centered around what OpenShift gives them. Another customer has the workflow more or less centered around the tools around Google Cloud. And neither one of them are bad. They're just different. And so I've got my own. I got multiple CI/CD flows that I end up plugging into. Is that a familiar experience? Is that just the way the rest of the world is, or is everything internally focused?
I think that's the. Go for it.
So it's just a question. Do you cover that? Do you discuss that? I would like to think I could pick one and I just live in that world, but I have to live in all sorts of different, similar but different CI/CD worlds.
Yeah, so I think that's a great point, right? Like when I'm covering in the book, it's more about like the idea of a team inside a company building a platform for other teams to consume, right?
Yes.
So in your scenario, it will fit all your customers, right? Like all your customers will have different tools, but you need common ways of describing those things. And for some internal teams, in your case, that are dealing with multiple customers, you will need to build the right kind of like level of abstractions to make sure that they can operate across different flows. Right?
Yes.
So what you will see here, like in the book, is that I try to show how you can actually build those things, that you work with the same concepts, but maybe the implementation and the tools behind those concepts are different. So you can create aggregations, for examples, or views that will aggregate all the different CI/CD flows into the same view, because conceptually they are doing the same but using different tools.
Yes.
Okay. I think that the answer to your question is that's why I spent kind of like the first part of the chapter trying to describe the concepts, because I know that if I go to OpenShift, they will be using one tool. And if you go to different cloud providers, they will probably be pushing for different tools.
Right.
And no matter what you do, you will need to get used to all of those flows.
Yes. Okay, thank you. Very interesting discussion.
And
very interesting.
Good, good, good. And I think that like going back to the trunk-based development theory question or comment, I think that that's great. Thank you very much for bringing that up. I think that what I mentioned there is it's coming much more from my experience on the field when I see people using one service, one repository, right? Like so, it's very small repositories where they do changes, and they just keep feature branches small because again, it's just a single service. It's not the entire system. But yeah, thank you very much for bringing that up. I think that including the link in the book might be a great addition. So I will just definitely review that and then just mention that because I think that that's important. Great. Yes, Carlos, that's true. We will not go there. Okay, perfect. So we are running out of time already. I think that we have 20 more minutes, but I really wanted to go into the second half. And in order to go to the second half of the chapter, where I just show some examples and some tools that are doing completely different things in the same space. And again, I couldn't mention all the tools, so I chose some. And I did have some reason why I chose the ones that I did, but I will go into that later. Before going there, I wanted to basically make sure that I mention this repository here. It's the repository of the book, and it has kind of like the examples that I will be mentioning now for you to run in your local laptops, like in your local environments. I'm running on Mac, and I tested most of the examples in Mac, but I have some people trying the same on Windows and also trying the same on Linux. And I think that the examples work, but again, just if you find any issues, the issues tab there, it's open, so feel free to report any issues on the examples. And as you can see, I'm covering kind of like three things here, like Tekton. It's like a cloud native project, Tekton.dev. This project is a little bit interesting on the history of the project and why it was created and all that stuff. Because it was part of a different project that it's called Knative, and it was separated because this project was focused on building stuff. So this is kind of like the CI part, CI/CD, because actually you can build any kind of pipelines here. But yeah, pretty interesting because it's kind of like Kubernetes native, right? Like the idea is that you can build pipelines and Kubernetes will be in charge of scheduling the tasks inside the pipeline and coordinating containers in this case. So it's kind of like a very interesting project that I wanted to mention, and that's why I go into showing that, right? I mentioned again, like I go into what you do, when do you run pipelines, how does it work, and then I go a little bit more into the specifics, right? Like in order to run pipelines, you need first of all a machine that will run the pipeline, and then you will need the places where you're going to store things, as we discussed before, maybe a Docker registry, maybe a Helm chart repository in the old days. Now you can deal basically, if you have a Docker registry, like a container registry, you can do whatever you want. And I guess that's a note here, just to change Docker for container registry in this case. So I go there and then I just try to describe kind of like how it will look like if you're using, a single service layout for just including everything from having a Docker file or using build packs, for example. The pipeline definition, maybe like if you do it with GitHub Actions, you usually have the workflows, description, like the GitHub Action description inside the repository. And then if you are just publishing Helm charts, you might have the chart with the manifest inside the same directory. That's, again, one possible layout that you can use and something that I've seen quite a lot in my years working with Kubernetes. It's not the only one. You can do different things as well, and you can separate code from, for example, manifest if you want to, or you can keep it all together if that works for you. Just want to have some examples to talk about then when I show the tools. There are options, limitations, and compromises, of course, as with everything else. And let me see here. Pipelines in Actions. Yes, this takes me back to the projects that I'm covering. And again, I'm covering Tekton. That's Tekton.dev. And I'm covering a much more newer project that it's called Dagger, that it's becoming a little bit more popular nowadays. At least in the last year, it has growing popularity, a completely different approach, right? And that's the main reason why I wanted to cover this. So basically, Tekton requires some time to get used to it because this is basically for pipelines that will run inside Kubernetes clusters, right? So the main reason to include an example and to mention the technology here is for you to understand that this is a tool, and this tool might be very relevant for platform engineers because it was built with the main concept in mind that you will create like shareable tasks definitions that platform teams can use to basically standardize across teams how containers are built, or how checks are performed on vulnerabilities, or any kind of like very specific task that your team wants to do. You can create a small library of resources that you can share and distribute for other teams to use. But you do it in a very Kubernetes way, right? So you have basically Kubernetes resources like task or pipeline, and then their runtime counterparts like task run and pipeline run that will basically represent executions of these pipelines. So creating kind of like a complete service pipeline, that the one that I mentioned here, like with all these steps in Tekton, will take you some time. And in order to do that, you need to understand how to construct each of these blocks and how to basically then coordinate these tasks with with the entire pipeline execution. And the moment that you start, needing infrastructure to be ready, like having a Git repository, you need to have credentials. You need to make sure that you have access to the servers that are running the registry, for example. You have the valid username and password and the right access to push containers there. So it gets more tricky if you want to run that in your laptop. And that's why I decided to say, okay, let's explain the basic concepts and how do you create a tasks in Tekton, how do you create a pipeline in Tekton that are doing very basic things without requiring a lot of infrastructure. But I also show, how you can create more like complicated tasks too. I think, if I'm not mistaken, OpenShift, for example, comes with Tekton inside, and all the pipelines that you can run inside OpenShift are basically Tekton-based pipelines. So learning this from in that context, I think that it makes a lot of sense. If you go here to the repository, basically you can actually create your pipelines and install Tekton, and also just run it locally. And you will see that Tekton comes with the Tekton dashboard, something that was highly appreciated by the Tekton community. I think that I have it. I don't have it running here. Sorry. It was really appreciated because actually you can see what the pipelines are doing. Initially, of course, because these are Kubernetes resources, you can connect to the cluster and check, if the pipeline run resource is created. But just checking on Kubernetes resources for pipeline execution doesn't make too much sense. So having a dashboard kind of like made this project very accessible and much more usable. Still, defining your entire pipelines using Kubernetes resources, it's quite complicated. So again, like tools like OpenShift will try to make it simpler, or it will try at least to make it accessible for the users to have access to very standardized pipelines to run. But behind the covers, you can actually do whatever you want with those pipelines, and you can actually create these tasks or entire pipelines definitions that you can share with other teams. And then I go again, like just talking about like what are the main things that you need to think when you're creating a tasks. How do you link the tasks inside pipelines? And I wanted to reach to this point where I mentioned Tekton Hub, which is, I think this is the important part, that no matter what kind of like CI tool are you using, you will find that they will have some kind of like marketplace of all the most common things that people are doing, right? Like creating a pull request from a pipeline. Of course, sometimes you want to do that, as I mentioned before. Maybe you want to send a pull request to an environment saying this new service is ready to be deployed. Or maybe you want to use build packs to create containers, or maybe you want to, clone some repository just to build source code. Send Telegram, just notifications. Maybe you want to integrate with Jenkins jobs that are running already and you want to reuse. That's something that you can do. Maybe you can just create like Helm charts or upgrade Helm charts in an environment. Use different builders and a bunch of other different things, right? Like, for example, interacting with AWS or interacting with, for example, Knative functions in this case. So as you can see, it's a large kind of like marketplace. There are tons of things that you can automatically reuse out of the box. So you don't need to actually create the basic tasks. You can actually use them from their marketplace. Pretty interesting stuff here. It's kind of like an interesting approach on pipelines on Kubernetes, because again, the engine itself that runs the pipelines, the one who decided where each task runs, is the Kubernetes scheduler itself. So that's kind of like Tekton. I try to cover the basics for you to get some hands-on experience. I think that that's really important to, if you are going through the book, if you run the examples, then you kind of know the strengths of the tools and also the limitations. Finally, I think that I try to finish kind of like Tekton saying, that there are tons of very good things about Tekton, and that's why it's being used in tools like OpenShift. But again, I think that the complexity of learning how to use Tekton will take kind of like a Kubernetes person quite some time. It's not an easy tool to get your head around when you start with it. Then it makes total sense, right? Like then when you look at how pipelines work and how do they get scheduled to be executed, it totally makes sense. But at the beginning, it's quite a complex tool to tame and just to start using to create like complex. But maybe for platform engineers, this is kind of like a good way of creating your componentized pipelines that can be shared across clusters. And remember, because this is running on top of Kubernetes, it will run across multiple cloud providers. So to the point of the question before of, we have OpenShift customers, you have Google Cloud customers. If you create these kind of pipelines, well, you can actually run the same pipelines in a cluster inside Google Cloud or, in an OpenShift cluster, it will be kind of like the same. But again, standardizing across, customers might be the harder challenge there. With that, I switched to talk a little bit about Dagger. Again, Dagger, it's a much more newer project. This was created by Solomon Hykes, one of the original authors of Docker. And basically what they are doing is something that I relate to it too much, basically, in the sense that what they have created is a pipeline engine with the main feature to be that you can run pipelines anywhere. You can run them locally, you can run them in GitHub Actions, or you can run them inside the Kubernetes cluster. They will run the same no matter where you are running them. And that's one of the things that you couldn't do with Tekton, right? Like Tekton requires you to have a Kubernetes cluster to run your pipelines. With Dagger, you are not doing that. You can just run the same pipeline locally on a different compute like GitHub Actions or in a Kubernetes cluster, and the pipeline will run the same. I think that this is a very, very interesting concept because, again, if I can only run GitHub Actions, I will need to, for example, push my code to a repository in order to see if the pipeline run and works. And I will not have like that fast feedback loop that I want to have as a developer to run the pipeline locally to see if I'm messing up with something before pushing. Nowadays, at least I don't know like what kind of computers do you have, but like I have like an Apple M1 that basically can run a lot of software really, really fast. So I would really appreciate to run my pipeline locally before pushing anything and wait for 5 minutes for a remote pipeline to run, right? So Dagger does that, and basically what I did is I use Dagger to create. I used like I think that nowadays it's an old version of Dagger to create pipelines for the application service that you were deploying last week in chapter 2. So if you go here to the Dagger section, you will see that, again, I'm just showing how to go to the conference application directory here. Let me open it in a new tab. And what you can see here is that all the service, like there is basically like a standardized service pipeline for all the services that basically will allow me to build, test, and package this application service codes, right? So there's a generic pipeline that I can parameterize for the different services, like the agenda service, the call for proposal service, the front end, and the notification service. If you check this is just Go code. And I think that this is the beautiful thing about Dagger is that they provide SDKs for most of the popular languages. So they have SDKs for Go. I think that they have one for Python, one for Node. They have one for Java and one for .NET. I don't know which ones of those are like community driven, but I think that the fact that they have SDKs for most of the languages is kind of good because you can now import the library and then you can start creating your pipelines basically programmatically. Right, so they allow you to write these pipelines programmatically. Again, you will be creating kind of like tasks. This is the pipeline here, like pretty simple stuff. So you have like a binary that you can run, and that will use the Dagger engine to run each of the steps of the pipeline as a container, right? Like it's not a OCI container, but it's a container of some sorts, right? Like it will just run the task. For example, if you want to build a service, we'll build the service, it will take the output artifacts, and it will use that to run the next thing, for example, testing the services. And then it will just look into those artifacts. If you want to publish something, you will just publish that with whatever credentials do you have and to whatever registry do you want to push that. So all of that can be kind of like parameterized in this case, but it's driven by code. I think that that's the important thing. And if you're like a Go developer writing these, it's pretty natural. You're using a library just to create these pipelines, and the pipeline itself is in code, so you can modify and read pretty easily. You don't need to learn about like how, like the GitHub action format or a format that it's been defined by your CI infrastructure, right? You can just do this by code. There are like advantages and disadvantages of doing that, of course, but I like the idea that you have that possibility. It really depends on what you're trying to do and if you like the approach of having things in code or not. So that's kind of like what Dagger does. And again, this pipeline, you can run this binary locally, and this will connect to the Dagger engine, or you can run this against the remote Dagger engine that might be running inside the Kubernetes cluster to run that inside Kubernetes if you want to. And the same, because it's a binary, you can just put that into GitHub Actions, and GitHub Actions can run that too. I think that now they are offering a cloud service too. I think that they have the Dagger cloud stuff, so you can actually run these pipelines in their engine, in their cloud engine remotely, which I think it's also pretty cool if you don't want to, if you want to reduce. I think that their main advantage here is that they can provide like much better performance and less costs to run pipelines that GitHub Actions, and I think that's why they are doing the cloud offering too. So I think it's pretty interesting. Check the pricing. I think that they released that it's like for developers. I think it's free. So if you want to build your own stuff, that's pretty cool. And for teams, I don't think that it's expensive. And again, I like the idea of the tool. So just check it out if you're interested in this. Again, there are tons of different services like this. I'm not saying that Dagger is unique, but the idea that you can just choose the SDKs, I think it's pretty important. And I think that it goes with the theme of the book that you need to choose the tools that are closer to your teams. So if your teams are using Java or if they're using Go, well, just try to look for tools that they can use. So try not to introduce a new tool that will be very difficult for everyone else to learn. And I think that that's pretty much it. I just show a very simple example here of like building the services of the application that are described there in the repository. And I think that I finished that by running the same pipelines on a remote Kubernetes cluster, right? So in your kind cluster locally, you can just have the engine there and it will actually run the pipelines in there as well. I think that this is like Dagger has been changing quite a lot lately, but I think that the examples are still operational and they work because I'm using a fixed version. So give it a try, and if it doesn't work, let me know. But I know that the Dagger folks want me to upgrade the example, so I might be upgrading this after KubeCon probably. And I think that that's pretty much it. I wanted to, at the end, just do kind of like a quick recap with GitHub Actions and comparing again the idea that you can, if like GitHub Actions are pretty popular, but you cannot run them locally, of course, that's kind of like one of the main things. Or maybe you can, but it's complicated. Tekton, it's very good because it uses natively Kubernetes and the Kubernetes scheduler to define and run the tasks. And Dagger, it's like a completely different approach where you can run pipelines anywhere. I think that was a thing that I wanted to mention in the book, that sometimes I see teams struggling because they are just waiting for pipelines to run remotely, and they can just be running those pipelines in their local laptops that are pretty powerful nowadays. So I think that's kind of like the chapter. And again, the chapter, if you take a look at the text, will go into these more abstract concepts that will let you to, kind of like understand different CI systems that are all using kind of like different nomenclature, but under the same concepts. And I think that with the examples, you can go deeper into thinking about, okay, I'm doing this in my current solution or in my company, I have these tools, how that would translate to the Kubernetes space, or to like the GitHub Action space, or to something that I can run locally using tools like Dagger. Of course, that cost is kind of like one of the reasons why you should look into pipeline executions, because the more pipelines you execute, the more compute you need. And cost also involves like people waiting for the pipelines to run. So I truly believe that improving cost and speed on pipeline executions is kind of like the job of platform engineers. Sooner or later, you will need to tackle that if you want to improve efficiency of your software delivery practices. And that's why I think that I created this chapter. So any questions or comments, highly appreciated.
I think it was a terrific chapter, especially with the Tekton. I have been interested in Tekton for a while, but it's quite hard to digest, I feel, just by looking at videos. But getting hands-on was really valuable.
Did you run through the examples?
Yes, and I liked it. But it's just the first step. The next step is to run and customize and understand all the flow.
I think that using the catalog, for example, checking the tasks inside the catalog and installing some of these tasks and just chaining that into simple examples is the next thing, definitely.
Yeah. No, I really like that chapter.
Perfect. And yes, of course, that you can run like GitHub Actions locally. There are some projects there. I think that when I last checked, you need to download like a huge image or something, like a 6 gigabyte stuff. Maybe not anymore, which would be great. Let me see. Yeah, I will just check it out later. But thank you for the pointer. I think that's a good thing to include. Okay, great. Another question from Kevin. That's really good. Does Tekton have any appreciable advantage over running self-hosted GitHub Actions runners in Kubernetes with action running controller? That's a very good question. I think that I think that like I would say that it's a different approach of solving the same problem, right? Tekton will not, like the only thing that Tekton will do is that probably, I'm not entirely sure if the GitHub Action runners should rely on the Kubernetes scheduler as well. So it's all about that, like, and I'm guessing that GitHub Action runners will just take GitHub Action definitions, which is reusing your current GitHub Actions if you're running on Microsoft Cloud, right? I don't know, Kevin, if you want to expand on that. But I wouldn't say that there are like any advantages on cost, for example. It's much more, I think that it's much more about like, what would you prefer as a tool to use? If your teams are already used to GitHub Actions and you have an efficient and cost-efficient way to run those on your Kubernetes clusters because you want to do that, that alternative, it's pretty good. And I think that, thank you very much for mentioning that, because I can look into that, and actually if I write the revision of the content, I can actually take a look into the Kubernetes controller for GitHub Actions in self-hosted runners, which is pretty cool. Yeah, I think that all those tools, that's the other thing that it's kind of interesting. That space is pretty fast and it changes quite a lot, right? When I started writing these chapters, it was funny. Like when I started writing these chapters, my main inspiration tool was a tool that now it didn't exist anymore. So it's like, okay, I started writing mostly based around that tool, and then I realized, okay, that tool, maybe it's still around, but it's not as popular as it should, which is how the industry works, right? So again, concepts over tools for me was really important, but also making sure that, I keep the door open for new approaches that will come, right? Great, folks. I think that it's the top of the hour, and that's chapter 3. I appreciate any comments. If you have any other things, please feel free to reach out. You know where to find me.
Thanks, Mauricio. This was awesome. Thank you.
Yeah, awesome session.
Thank you, folks.
Thank you.
Thank you. Bye.
I will try to join the next one.
Safe travels, everyone going to
Thanks,
KubeCon.
bye.
I hope it was there.
See you at KubeCon, folks. Yeah.